Okay, well, welcome to this video. What we're going to do in this video is we're going to look at paper 3, so the final geography paper. We're going to look over what might be topics you want to look at. We're going to look at what paper 3 involves, and we're then going to look at the fieldwork questions. So let's get started. So the first thing is, what will paper 3 actually look like? And if you look here, this is what it will look like on the front. You'll notice it says transects and inequalities, hour and a half, and you'll also see it's got 3 parts. And that's really important to understand. So part A is going to be 18 questions, or 18 marks, sorry, about transects. And 6 of those will be on your work that you did in Barton on C. Part B will look at inequality. And again, inequality, 18 marks, of which 6 marks will be about fieldwork, and you can talk about Barton or Bicester there. And then finally, part C looks at about half the marks, in fact, is actually a decision-making exercise. It's a mini version of paper 2, that paper that went quite well for you guys. And this will be based on inequality, so it'll be about differences between places, and it'll be a mini version of that paper 2. Now, what sort of topics can come up? Only questions that are based about the UK. So you have no global cities or anything like that. So things like rivers in the UK, coasts in the UK, urban areas in the UK, rural areas in the UK, things like shopping perhaps. Could be leisure use, could be looking at UK-based ecosystems, but it won't be tropical rainforests, it won't be global cities, it won't be semi-arid grasslands or anything like that. It has to be a UK-based case study. Okay, so that's what the exam paper is going to, or how the exam is going to be structured. So let's get started with perhaps the most important thing. So we're going to look at paper section A and B in particular. And the key bit here is that you know these 2 key terms. The first thing you have to know is what inequality means. Inequality is a difference between 2 areas. Now that may be inequality in terms of coastal erosion risk, which we looked at in terms of Barton. It could be flood risk. It could be inequality in terms of quality of life, which is what we looked at in Bicester when we compared King's End with Kingsmere. It could be inequality in life expectancy, anything like that. It's a difference between 2 areas. And part B is going to look at inequality, but so is part C. So you need to make sure you understand what inequality means. Okay, that's really important. Now part A will look at transects. And transects is just a fancy way of saying a line along which data is collected. And you did 2 of those. You did the cliff profiles when you went up the cliff, and you did risk profiles, transects, sorry, along the cliff as we walked along the roads at Barton. And then there are 2 terms that the exam board likes to use repeatedly. One is reliability, which is basically, I mean, this should be the same as what you've learned in science, the extent to which measures are consistent. So if you went down there tomorrow, would you get the same results? And accuracy, which is how close your data represents the actual truth. So those are key terms that we're going to use over and over again in this session. You have to know them. You particularly have to know inequality and transect, because the whole exam is based around those. Now, one of the things that you have to be aware of is that the fieldwork questions are going to be taken from this diagram. This is the 6 stages of fieldwork. And you've got stage 1, which is about posing questions. You've got stage 2, which is about collecting data. Stage 3 is about processing and presenting that data. 4 is about linking it to wider understanding. 5 is drawing conclusions. And 6 is evaluating the process. So if you just stop for a second, look at those statements on the left, where would they go? I'll let you pause the video. Okay, if you had a chance to do that, that's great. And you'll see they've been totally unimaginative. Okay, identify improvements is number 1. Think of a key question would go as number 2. Go to Barton would be number 3. Draw a locational bar graph, well, that would be processes and presenting data. Number 5, look at a textbook would be applying your wider understanding. And to write a conclusion, number 6 goes in draw conclusions. Now, obviously, you start this with posed questions, but again, you're going to see that the questions they ask come from one of these 6 areas. Okay, so moving on, let's start with the first one, posing questions. Now, there are 2 types or 2 ways in which geographers pose questions. There's either hypothesis, which is a statement to be tested, or a key question, which is a question to be answered. Both are perfectly acceptable, but you need to be able to come up with both. So have a look at these. So number one, King's End is more deprived than Kingsmere. Is that a hypothesis or is that a key question? And number two, how does risk from erosion change along the coast of Barton? Again, is that a hypothesis or is that a key question? Okay, give yourself 2 seconds, and when you pause the video, and when you think you know the answer, press play. Okay, well, obviously the easiest way of telling this is which one's got a question mark. Okay, questions have to have question marks. So how does risk from erosion change along the coast of Barton is the inquiry question we used when we went to Barton. So that is a key question. Whereas King's End is more deprived than Kingsmere, hasn't got a question mark. It's not a question, it's a statement. And that means it's a hypothesis. So you may well get questions where you're asked to identify key questions or hypothesis linked to inequality or transects. And just to show you what it might look like in an exam, this was taken from an exam a couple of years back. And it says, here's a photo of central London. 2 hypotheses that could be investigated using a transect in the environment shown in the photograph. And the key bit to remember here is that transects measure change over distance. So if you look at these two, you'll see that there's 2 here. First of all, there's the risk of flooding decreases with distance from the river. So that is basically how much does the risk change as I move away from the river. So it's change over distance. And then the second one here is buildings increase in height as you get closer to the CBD, so the city centre. And again, the idea here is as I go towards the CBD, the buildings are getting higher, so it's change over distance. If it was about inequality, again, it'd be a similar sort of question. It might be, have a look at these 2 photos, which hypotheses or which key questions could be used to measure inequality, testing you understand what a transect is and inequality. So you might well get something like that. They certainly come up fairly often. Read the questions, make sure you're clear, is it transects or inequality you've been asked to do and what ones work. Okay, so let's move on. So you are going to get questions about sampling, okay? And you're going to need to know the different types of sampling. The best thing you can do here is look on the knowledge organizer we gave you, and that's where this has come from, this table, and you simply have to know what each one is, the advantages and the disadvantages. Now, the most important, if you're going to learn one of these, it's systematic sampling, because that's what we actually did. And systematic sampling is when we measured the risk from coastal erosion every 100 metres. And the advantage of that, it gives a good spread, an even spread at that. It's relatively easy to do, okay, and is fairly simplistic. It takes away personal choice, so it reduces bias. The problem with this one, okay, is that it can be time consuming. It can still have bias because there isn't an equal chance of everything coming up. So a good example would be if I was trying to find out the opinions of students and I went and spoke to the nearest child to the door in every classroom. Now, that may well reduce bias in I'm not picking which child it is, but there's a good chance there's a reason why that kid sat next to the door. Maybe they need to loo all the time, or maybe they're quite disruptive. It's potentially biased. So even though I've got a system, there's still a chance it's not a representative sample. And when we were doing transects and using systematic sampling, we had problems because we were trying to do it along a line, but the line went through a gorse bush, which cut us to shreds, so we had to go around it. So it might be that not all sites are accessible. You could do random sampling, and random sampling is brilliant. There's no bias whatsoever, although picking random sites is incredibly difficult. You need to get a computer to do it or something like that randomly. But because it's completely random, you have no control over where the sites are. It could be that they're all clustered in one place. So you might do 100 square miles of land you're investigating, and you suddenly discover that your 10 sites are all within 10 metres of each other. Okay, so that can be an issue. And then finally, stratified sampling is the most complicated one. And we'll have a look at a really horrible question in a second about this. But this is basically looking at the groups you've got. So if I've got a class of 30 students and 20 are male and a female, what I would then do is when I was doing questionnaires, I would do, I don't know, 10 male, 5 female. And it's basically reflecting the percentages that we've got there. The problem with that is that you need to know what's there already. So it can be quite difficult. Okay, so you've got to be careful of that. And then finally, there's something called opportunistic sampling, which isn't really sampling at all. And it's basically doing what's easy. Okay, I'm going to ask these people because there's lots of them and I can't be bothered to work out a sampling strategy. The problem with doing that is I may get a very big sample size, but it's obviously very risky in terms of bias. Now, two things. You get a question about improving any data collection. Use a sampling technique, systematic sampling to make sure you've got an even spread and to reduce the risk of bias. And the other thing, which is nearly always the correct answer, is to increase the sample size. The bigger the sample size, more representative it is, the lower the risk of it being an unrepresentative sample. So what would an exam question look like? So an exam question might look something like this one. Okay, here's a transect. The students use systematic sampling, give 2 advantages using systematic sampling to collect the data on this transect. Again, stop the video, give yourself 30 seconds, what have you come up with? Okay, so if I was doing this, the sort of thing that I would come up with is that systematic sampling ensures an even spread. It's easy to carry out. It reduces the risk of bias as the sites are predetermined. I'm not going to wear a fancy. So it's got lots of advantages. Right, stratified sampling. I did say that this was horrible. So stratified sampling, remember, is when you work out the percentage of something and then you do that percentage of your samples comes from there. So in the example I gave, 2/3 of our class was male. So 2/3 of any questionnaires I do to that class will be male. 1/3 were female. 1/3 of the questionnaires I do will be female. And this is about as horrible a question as they can give you. So if you can do this, you'll be fine. So it says they want to interview 100 residents at a town called Bulf. They've used a census data, so they've used some secondary data to find out that 2,070 people live there. 460 of them are over 65. How many questionnaires should they ask? Over 65s, 30 to 64s, under 30s. And the way you do this is, first of all, don't panic. Okay, stratified sampling is all about calculating percentages. You've done that a million times in maths. So if we do 65s, there's 460 of them out of 270. So I'm going to do 460 divided by 2070. That will give me a number of 0.22222, times it by 100% to turn it into percentages, 22.2%. There are 100 questionnaires, so 22.2% of 100 is going to be 22, just rounding up to the nearest number. And I would just repeat that for 30 to 64 and under 30, and then fill that in and make sure this adds up to 100. And this is extra nasty, this, because it doesn't. It adds up to 99 as rounding issues. So in which case, just bung an extra one on the largest and you'll be fine. So that's the worst I can ask you, I reckon, about stratified sampling. If you can do that, you'll be absolutely fine. Okay, so that's sampling done. What about making the data more reliable? This is basically about making your measurements more repeatable, more consistent, basically making them better. Okay, give yourself 30 seconds. How could you increase the reliability of any data we collected, whether it be at Barton or whether that be at Bicester? So stop the video, have a think, and we'll go through it in a second. Okay, so let's see what you come up with. Well, I've come up with the following. So, first of all, okay, I can increase the sample size. Anything about improving data measurements or anything like that, normally increasing the sample size is going to be correct. I could collect at different times and days. If I was measuring traffic and I measured it during rush hour, I'd have loads. If I came back at 11 o'clock in the night, I'd have less. If I did it on a weekday, I'd have more. If I did it at the weekend, I'd have less. So collecting at different times, okay, different days, will improve it. When we were taking measurements with the clinometers, those sort of gun things to measure angles, they were awful. So we took 3 and we took the middle number. Okay, that reduces the impact of outliers. It means our data is probably more accurate, but also more reliable. And we can make sure that we've got some sort of anything that's going to reduce the risk of bias, some sort of sampling strategy. So they're the sort of things to think about. But again, what would an exam question look like? So let's have a look at one. So this one is about your own field work. And again, it's a transect question. Suggests two ways that you could make your transects more reliable. Now remember, we did two transects. We did a transect going up the cliff to see whether the cliff was stable. And we did one along the cliff and then along another road to see about the coastal risk. So how could you actually make it more reliable? Again, stop the video, give yourself 5 seconds, and then I'll go through it. Okay, so this is what I came up with. So you can increase the sample size. So when we were measuring the coastal risk, we did it every 100 metres. We could do it every 50 metres. Okay, increasing the sample size means I've got a more representative sample. It's more likely to be reliable. I could have used more than 2 transects. Okay, I could actually have had 3 transects. I could have gone north-south as well as east-west. So again, increasing the sample size. And then if there's any oddity on one transect, like an outlier or something, it'll be picked up by because none of the others will be the same. Or I could have used random sampling or something like that to select the samples. We used opportunistic sampling. I basically picked what was most convenient, okay, which made us easier, but actually there was no scientific rationale behind why we picked those other than they just happened to be the most convenient place. So any of those could improve the use of transects. You could have repeated the transects on a different day, see if that affected any opinions, although probably not given the data we were collecting. So that's your own data and using transects. What about if you were like doing a section that's perhaps on the inequality section or something like this? So this is from a slightly different exam paper. It's looking at qualitative data. You don't need to worry about that. But the sampling question could almost be word for word what comes up in yours. So they were looking at people's opinions about the town, and they sampled the entrance of a bus station at point X on the photo. So there's a bus station, you can see they've got it sort of labelled. So what's good about using the entrance to a bus stop? What's bad? Right, you're used to the drill by now. 30 seconds, stop the video, have a think, see if we can think of the answers. Okay, so first of all, what's really good is that you're in a busy bus stop, you're going to have a big sample size. Lots of people waiting, lots of people who won't run away from you because they don't want to lose their bus place when you say, could you fill in a questionnaire? So bus stops are brilliant for getting big samples. But there's a downside to bus stops. Okay, people who use buses don't perhaps own cars. People who use buses don't live in the town. People who use buses are probably more likely to be children or old age pensioners or commuters. So you're not going to get a representative sample. So that would be the sort of perfect answer, okay, to that question. So those sort of sampling questions you might get, and you'd probably get them under transects, you might get them under the inequality. Right, then you might get a question about transects themselves. And again, the important bit about this is you must know what a transect is. It is a line along which data is measured. So why do we use them? Well, we use them because they measure change over distance. If there's one thing I want you to remember going into the exam, is that transects measure change over distance. They're quick and easy to use, and you can collect multiple pieces of data along the same transect. So if you think about it, when we were doing the risk survey, we looked at the distance from the sea, we looked at how the land was being used, and we also evaluated the coastal defences. So again, okay, we know what transects are, we know why they're useful. What would an exam question look like? So let's have a look. So this is a typical one. It will give you some examples. So students could have done these transects, or they could have done these transects, but they chose these ones. And it says 4 marks, suggest why they chose these. And it's kind of spot the difference. Okay, if you look at the top one, the lines are longer and they're straighter. Well, instantly I'm thinking they're my answers. So if I was to try and explain why, well, they're longer, which means they cover a wider area, and they're straighter. Remember, the idea of a transect is change over distance. Well, if you're trying to analyse how something changes over distance, going in a straight line is a hell of a lot better than a crooked, wiggly line. So that's how I'd answer that one. Okay. But you might also be presented with a transect and basically asked to interpret it. And again, this is an example. This one shows footpath erosion. I could almost imagine them doing something similar with a sort of meander, cross-section of a meander, where you've got sort of like the erosion on the outside of the bend, and you've got the sort of beach bar, so beach, river beach, point bar, or whatever on the inside where there's deposition. And this one's really simple. Again, it gives you a photo, it gives you a cross-section, and you simply have to decide which of these statements go where. And if you look, greatest erosion at the edge of the path, well, that's not true. Soil's deepest because plants have been killed by walkers. Well, it's deepest there, there's no plants, that must be true. Most soil erosion in the middle of the path, where there's most walkers. Actually, I'm not sure I'm convinced by that one. In the middle doesn't seem to be the most. Vegetation is tallest in the middle of the path, that's not true. Vegetation is largely unaffected where there are a few walkers. And again, if I look over here, that's true. So again, really simple multiple choice type question. We're interpreting some results from transect. Now, you may well, in fact, you will get asked about your own use of transects. And the worst they can ask you is 6 marks. Okay, and I reckon this is about the hardest one they can do. So evaluate the strengths and weaknesses using transect to collect your data. And you use transect to investigate the risk from erosion at Barton-on-Sea. So you do need to know what you are using transects for. And then evaluation. And again, tell me what's good, tell me what's bad. 6 marks, I'm after 3 points. There's 4 down here. I'd make sure you've got some negatives in there and make sure you've got a couple of positives as well if you can include it. So what was good about it? Well, we know that transects cover a wide area, and importantly, to get 6 marks, you've got to link it to your fieldwork. So notice I've said from central Barton to the edge of town, so I'm showing specific to my fieldwork. 2 transects, one next to sea and one inland. Okay, again, relating it to Barton. It was quick, it was easy, and it allowed for systematic sampling to reduce the risk of bias. We collected multiple data at different points, e.g. land use and distance from the sea. Again, that made it quicker. But we couldn't go in a straight line because we had to follow the roads, so we had to use opportunistic sampling to the risk of bias. So that, I reckon, is about the worst question they can ask in transects. If you can remember that, you'll be absolutely fine. Okay. Now, let's move on to collect data. Every year there has been a bipolar question. Okay, I don't think there's been a year where they haven't asked a bipolar question. So we better cover those. And bipolars, you've used them in both pieces of fieldwork, are just simply surveys that have a pair of opposite statements and you judge them. And it might be between +3 and -3, or +2 and -2, or it might be +5, guess what, to -5. And if you're asked to evaluate them, they're quick, they're easy, they provide quantitative data, numerical data, easy to analyse, but they're also disadvantage is they're opinion-based. They are asking you whether you think something ugly or attractive, so therefore they're inherently subjective, which means that they do lack reliability because a different person would get a different set of results. What would this look like in an exam? Well, it nearly always looks like this. Here's a bipolar. Here are some blank rows, fill them in. And what you have to remember is that you need a positive and a negative. So this one, read the question. It says, the students used a bipolar technique to record how people felt about different parts of Newham. Part of the draft survey is given here, and 2 more pairs of bipolar statements that could use to investigate access to services in the study of inequality. Well, access to services means that you're near shops, you're near schools, hospitals, buses, railways, things like that. So anything like lots of shops, few shops, near schools, not near schools, they just have to be opposite. And as long as they're opposites and they're linked to services, you're absolutely fine. Okay, so it should be really nice and easy, those sort of questions. Just remember they're pairs. Just one thing before we move on, you'll notice there's no 0 here. For some unknown reason, the EDUCAS exam board loves bipolars with no 0. Everywhere else has them. And the argument for that is that if you give people a midway point, they'll opt out and they'll say, meh, 0. It's worth remembering that, and we'll come on to that in the next question. So what would it look like if they asked you about this sort of thing for your own fieldwork? So again, another nasty question. I don't think it's that nasty if you know the answers, but it might ask you to evaluate a data collection sheet. So this is asking you about some sheet where you collected information. And this is the one that we used to do the, what am I trying to say? To do the inequality between King's End and Kingsmere. It's a bipolar. This one goes +2, +1, 0, -1, -2. You'll notice it's got 19 sets of data covering 4 different areas. So it carries out a wide amount of different data for each location. You'll notice that it's got the site, the location, and a general description. So it allows you to clearly identify where it is. That's really good when you want to analyze it. It's quick to carry out. You guys were doing this in like 2 minutes, but there are some problems with it because remember, it's an evaluate question. I've got to say the negatives. It is subjective. Different people had different answers, even though you were all looking at the same place. And we use 0, which I personally don't think is a problem, but you could say means that you can actually give 0 and avoid having to make a decision. So you can basically give the researcher an opt-out without having to say positive or negative. So that's the sort of way you'd answer that question. Okay, moving on. Now there are going to be questions about data presentation and improving data presentation. And when there are, the things to sort, this isn't an exclusive list, things to look for: scale. Has it got a scale bar on it? Is it drawn to scale? Could it be color coded? So this one here we'll talk about in a second, but look, what we've got: bank, bank, bank. Well, they could be color coded. Is there a north arrow? Do I know which way the map's orientated? Is there a key? Is it legible? And so a typical question might be, here's some data, tell me 2 ways it could be improved. Well, all of these would work, wouldn't it? Hasn't got scale. Is it drawn to scale? Okay, is the mobile phone shop the same width as the bank? I don't know, I can't tell, there isn't scale. Could colour code the different types of shops and make it clearer. I could have a north arrow because I don't know which orientation the street's in. Probably a key isn't necessary at this point, but if they were colour coded, it would be. Any 2 of those will get you the marks. You might also be given some graphical information, and this is a classic one. Which one of these 2 graphs is the best way of presenting this data? So this data is looking at, looks like airports, maybe it's the number of passengers or flights or imports and exports. Oh, there you go. And you're asked to say which one's better. Now, the important thing here is to ask yourself, is it continuous data? Or is it sort of discrete, non-continuous data, categorical data? And it ain't continuous. There's no, if you look at the axes at the bottom, it's not time, it's not distance. So it shouldn't be a line graph. So it should be the bar graph. So with this one, you need to make sure that you're happy at knowing the difference between continuous and non-continuous discrete data, and that you can only show a line graph when you've got continuous data. So that's the most important thing. The other thing is to think about how easy it is to read. So if you look here, that's quite clear. These are actually quite confusing, whether at an angle. That would be my other point. So you might get questions like that. Again, don't panic, think about it. Make sure you know your different types of data. You've done it in maths, you'll be fine. Right, you may also be asked to talk about how you presented your data. So again, this could be a challenging question, but not if you know the answer. It's very easy. Evaluate the strengths and weaknesses of one method you use to present your data using transects to show inequality. Right, for both Vista and for Barton, we use locational bar graphs, and these are a nice example of the sort of locational bar graphs you should have drawn. The bigger the bar, the greater the risk. So why did we use locational bar graphs? Because they look fancy, yes, but they allow for what's called geospatial or spatial patterns. Look, if you look here, the bars here are small, the bars here are long. Okay, the risk is greater here, it's less over here. And that's not surprising because this is the area being defended, this is the area not being defended. If you look at the bars near the sea, they are higher than the bars away from the sea. And that's not surprising because they're more likely to fall into the sea. So the most beneficial thing here is it allows you to do what we call geospatial analysis or spatial analysis. It allows you to see where things are. You've got a map. So look, you can see over here, that's the holiday village. You can see where the cliffs are. So it allows you to look at where the risk is and look at what the land use is underneath it. It's pretty clear and easy to read because you're using bars, and there is a bit of a problem, which is that the bars cover up part of the map. So you can't actually see what's underneath the bars. So that's a sort of limitation. Okay, so the final part is about conclusions and evaluation. Now, what you might get is a question where they present, and they probably almost certainly will, present you with some data. That data may be in the form of a sort of map here with sort of numbers on, where I guess they could get you to plot ISO lines, like lines of equal, whatever that is, values, where you join up all the threes and things. Or in this case, they're just asking you to describe the pattern. And if you look at it, just say what you can see. You know, nothing on here will be there for random. So there's a playing field and there's a park. Oh, look at that, the scores are higher next to them. So conclusion one, that bipolar scores are higher than near parks and playing fields. If you look at those main roads, and guess what? The main roads have got the lowest scores. Okay, so scores are lower on main roads. Local shops seem to lower the score. In fact, the worst scores are found near the lowest, and the scores near the school are high. Three conclusions. All I've done is literally said what's there. It probably won't be this. It'll probably be a table. It could well be that, but it's probably a table of data. And particularly doing inequality, think similarities and differences when you come to do your conclusions. Right, and finally, possibly the nastiest question they could ask. So if you know what you're doing about this one, you'll be absolutely fine. Evaluate the reliability of your conclusions into inequality. So you can either do this on Bista or you can do this for Barton. I think I'm going to talk about Barton from memory. And the important bit here is you start off by saying what your conclusions are. So what would my conclusions be? My conclusions would be, he says, just clicking on the right button, that there was a significant variation in risk from coastal erosion between central Barton, which was low, and West Barton, which was high, and this is because of the lack of effective coastal defences in the west. So my first sentence on this one is say what the conclusions are. I don't go into that anymore. Now it's about the reliability of those conclusions. How confident am I that if I went down there again, I'd get the same results? So I need to think about what was good about my investigation and why I'm confident in it. So the next bit is tell me what's good about it. So if you think about it, you did a risk survey. It showed that the risk was highest in the west. You did field sketches, and that showed the erosion was fastest in the west. You did bipolars, looking at the coastal protection and the management. There was none in the west. We looked at house prices. They tended to be lower in the west. All of this all pointed to the same conclusions. Now, the technical name for that is triangulation. You're able to triangulate your data, and because they all pointed to the same thing, you're confident they're reliable. Even when you look at individual bits of data, like the locational bar graph, there's a really clear geographical pattern. So again, you should be fairly confident. And when we were collecting data, particularly the risk, we use systematic sampling to reduce the risk of bias and to ensure good coverage. So again, that means that we're more confident we've got a representative sample, which makes our conclusions reliable. But it wasn't perfect. Okay, we could only do one cliff profile as the area was too dangerous to the west. And when we were doing land value and house prices, we used Zoopla. We had to use historic house prices, which were in some cases a couple of years old, so may have been out of date. So there are questions about the reliability and accuracy of some of our data, which means that our conclusions might have been slightly unreliable. But overall, the fact that it all said the same thing means we're fairly confident. The risk, if house is going to fall into the sea, it's going to be where there's no sea defences. It makes perfect sense. Now, this doesn't cover everything in this video. I haven't, for example, talked about secondary data, which we take that Zoopla thing is a good example. So secondary data, the advantage is you get access to data that you don't normally have access to. You certainly couldn't collect yourself. The disadvantage is that it's inaccurate, it might be biased, it might be out of date. So there's still a couple of things here we haven't covered. They are on that knowledge organizer. Use that. Learn everything on that knowledge organizer. Test yourself on the questions at the end, and if you can do that, it'll be fine. We'll be around tomorrow during the day. If you've got any questions, come and find us. Right. hopefully that's really useful. If you are any questions, you're welcome to email me tonight at matthew.brown@thebisterschool.org.uk or catch me tomorrow. So good luck, hope physics or whatever it is tomorrow goes well, and hopefully you're in a good place for geography too. Yeah, cheers.